What's up, everybody? We're back on FreeCodeCamp.org with another daily code challenge. This one is for September 27th, 2025, and this is called Spam Detector. Given a phone number in the format +A parentheses BBB CCC-DDD with spaces in between, where each letter represents a digit as follows. A represents the country code. It can be any number of digits. So that's that guy right there. BBB represents the area code and will always be 3 digits. CCC and DDD represent the local number and will always be 3 and 4 digits long, respectively. We need to determine if it's a spam number based on the following criteria. The country code is greater than 2 digits long, or doesn't begin with a 0. The area code is greater than 900 or less than 200. The sum of the first 3 digits of the local number appears within the last 4 digits of the local number, or the number has the same digit 4 or more times in a row, ignoring the formatting characters. Those constraints right there dictate that this is a spam number. Okay, and we have our test cases here. So this one is false. This is not a spam number. Its country code is a 0. And we look up here, the country code is greater than 2 digits long or doesn't begin with a 0. So it looks like if the country code is greater than 2 digits and begins with a 0, then it is spam. I think that's what that means. So it can just be a 0 and that's fine. Area code is 200, so it's not less than 200. And if we add up these guys, which would be 9, 3 plus 4 is 7, plus 2 is 9. 9 doesn't appear in the last 4 digits. So those are the reasons that this one is not a spam number. So to get a better understanding of this stuff, we could step through each test case and reason about why it is a spam number, because it looks like most of these test cases are true. So all of these from 2 to 7 are all spam numbers. And so when you're devising your solution, you can be kind of checking against the reasoning of what makes each of these a spam number. For instance, this one, 5 plus 3 plus 1 is 9, and 9 shows up in the last 4 digits of the local part. This one has 4 5s in a row right there. That's the reason that this one is a spam number. This one has an area code that's greater than 900. That's the reason this one's a spam number. This one, I think this one is a spam number because it begins with a 1. Because this would add up to be 12. I would assume you can't have that because it's talking about each individual digit. So that leads me to believe that the country code constraint means that it's either or. So either the country code is greater than 2 digits long, that means it's a spam number, or it doesn't begin with a 0. And this one does not begin with a 0, it begins with a 1. So that's what I would recommend in approaching this. How about we step through each situation and I'll just code up what comes to mind. It won't be pretty code. And then we can do a second pass, like we get that first version of the code passing all the test cases, and then we step back through and I can demonstrate how to clean up the code. That's kind of how I would probably approach this. So I will check for duplicates, and I'll do that by iterating, because that's kind of the most clear thing to me. The other 3 constraints will have to probably split up the string that we're getting, the number string, in order to part this out and check each part. But this one, we're checking the entire thing. So we'd be able to iterate through the numbers. I don't know. Let's see. Before I say anything more, let's just iterate through the numbers. And let's check if it's a symbol, that means it's not gonna be 0 through 9. And we can test the number at this iteration for that condition. If it's not 0 through 9, then we can just continue iterating and go to the next place. go to the next item. If we have, so each iteration I will push into duplicates. So we'll always be checking against the previous item. So the first pass will come through and it'll just push the first digit into this duplicates array. Then the second pass will be checking to make sure, okay, do I have something in the duplicates array? And we could say, you know, greater than 0 or something, but this works too, because if the length is 0, it will be falsy. So that would be a false condition, and it would short circuit these two conditions I'm going to put here with the and. Duplicates at, okay, so I'm going to just make this easier for typing, since we're going to rewrite this anyway. I don't think this part of the code is going to go into our final solution, but I'm just going to say it's the D array, and that's easier to type here. A little bit of laziness. It's not super readable. If it's easier for you to reason about this with the full duplicates name, then that, I would say that's fine. Let me think about this because I'm talking. So if the last number in the duplicates array is not equal to this number that we got out of the string, then we're going to clear out the duplicates array. So this is the condition that on the second pass, if we have something in the array and the last thing we put into the array isn't this same number in this iteration, then clear it out, because that didn't even, we just want to, I don't know how to phrase this. We want to keep the duplicates array clear unless we get the same number more than once. And that's what this ensures. And then our exit condition is that if we got that same number, then the array isn't going to clear. And then we're going to hit the next iteration and it's not going to clear. And we're going to hit the next iteration. And so by the time we get 3 digits, I guess, because this has to be 4 or more. The number has the same digit 4 or more times in a row. So by the time we get to the 3rd digit in the duplicates array, that means that we have a spam number, because we're about to put in the same digit the 4th time. Okay, next, we know we'll have to split this into parts. So I'm just going to say parts and number, and we'll split it on the space. So now we have an array of, plus a parentheses, BBB parentheses, and then this third part, which is the local part. And now I guess we can deal with the country code. We'll just go part by part by part. And the country code is going to be parts at index 0. So I can take parts at index 0, and I guess just to get the plus sign out of the way, I'll substring it off of the index 1 to the length of parts 0. Kind of debating, like it'd be a little bit verbose, but we could like do country code parts index 0, and now we deal with country code. Oh, not an index 0. Yeah, this is a little bit easier to reason about. This would produce the actual country number without the plus sign. Then we could take the country num if it's longer than 2, which is our first constraint for the country code, or the country code doesn't begin with 0, and this has to be the string 0. So if the country code is greater than 2 digits long, or the country code doesn't begin with a 0, then we will be returning true. It's spam. just to like sanity check before I keep going, what we could do is just grab this number that has a country code of 3 digits and set the number to that. And I will just console out something to confirm that it's returning true here, because it could also return true here. There isn't duplicates, but if this duplicate's code is flawed, then we would get cheese. All right. And we got potato. So it hit this line 23 and returned true the way I expected. Yeah. So I'll keep these console logs here as we move to the next constraint for area code is greater than 900 or less than 200. That's not too hard because we can get the area code from the first index of parts and substring off the parentheses. So we would start at the index 1 and we would go substring is inclusive. We would get the second to last item in this in the parts index 1. And area is greater than 900 or area is less than 200, return true. And let's see, what's your favorite food? Say ice cream. What is one of these? Here you go. Here's a test case that has an area code 955. 955 area code should get us some ice cream here. Yes, we got ice cream and that looks like it's working. And now this one, I guess we could split the parts index 2, because parts index 2 is going to be our local part. Parts index 2, and if we split it at the dash, then that means we will have the local part, and now the local part will be 2 parts, the 3 digits and the 4 digits. And we could reduce this and sum it, but I will just do a simple for loop. For let I 0 I is less than local at 0 length. So this will iterate through the local index 0, which is our 3 digits that we have to add up and then check to see if that sum is somewhere in the last 4 digits. And since these are strings, I should parse it as an int. So I will add it to the sum, parse int, and what is it? It's local at index 0 at index I, because we're iterating through local at index 0. Yes. Okay. And that means that the sum is included if the local index 1 includes sum, and now we have to convert this back to a string, I think, because we just added it together, parsing as the int, so sum is going to remain a number, and now that we're checking it against the local index 1, which is a string, we have to convert the sum back to a string. And if sum is included, then we return true. And here we'll return apple. Just looking at this, I think that looks correct to me. But now let's look for a case that has, yeah, I remember seeing that case. So we have this guy here that we can set as the number at the top. 5 plus 3 plus 1 equals 9. So this should console out apple. Yes. We have our apple, and we didn't get ice cream or potato or cheese. So that tells me we're done, I think. We would, at the very end, return false. And I'll get rid of these console logs. Well, I won't get rid of the console logs yet because I haven't ran the full test case suite. So let's hold our breath, run the tests. No, we're returning. Oh yeah, because I didn't remove the, here, I'll comment out the number. All right, keep holding your breath, run the tests. Hey, I am glad that I didn't have to go back through and try to debug that, because that has a lot of annoying array access stuff. So let's do this again, but now let's do it so that we don't have to access the array and then the array of the array and do all that funny business. Just going to reset the lesson. Let's start over and let's think about this over again, but now, well, actually, I don't know. Let's get the regex first, right? Let's just call it regex, and this will be a little bit difficult. It'll be easier if we go from start to end. So the caret signifies start of the string, and the $sign signifies end of the string. The caret has a double meaning if you put the caret in a group, so like a bracket or parentheses, then it means not. But the caret just bare at the beginning of the regex means, hey, I'm looking at things from the start of the regex on to the $sign, which is the end of the regex, or end of the string, looking at the whole string here. So let's make sure, I'm trying to think of how I would do this if I was in like an app, like a production environment, so to speak. I would just check the format altogether. Like, did we get the right format? So that's parentheses and then escape parentheses. So see how I have escaped parentheses on either side here? And now I have a parentheses in between them that signifies the capture group for 3 digits. So this is digit here 3 times. And then we have another capture group that is 3 digits and a dash, and then another capture group that is 4 digits. And close off the capture group. I think that is our phone number. And if we match it, we're going to end up with an array. Well, we may end up with like null or false or something if it doesn't match the stuff. In which case, I don't know what we would return. It's not in the test cases, but I would assume if a number shows up and it doesn't even look like a phone number, it's probably spam. So I'll take the number and match it against this regex that we just wrote. And now if the match value is falsy, I think it ends up coming back as null if it doesn't match on it. We'll return false. No, we'll return true. True, it's spam. So that's not really part of the challenge. It's helpful because it gets us this. We have this first item, so this is all coming out of match, right? So I have match that is an array, and I can destructure this array where the first index of the array of match is the whole entire matched string, I believe. But we also have a country code. We also have an area code. So I will shorten this up and just say country, area, local 1, and local 2. So this code here at the top saves us from splitting it and accessing different parts of the arrays that we get when we split the string. Then we can go through and just do what we did here. If the country code is greater than 2, or the country code doesn't start with a 0. So that may be a better way, because I think what I did before was like country index 0 does not equal string 0, but our string has a starts with method that we could use. And if that's the case, we'll return true. Then we have our area, which is a number. I think we can do this, and it will type coerce. I don't know. Area is a string. Does this compare it correctly to the number 900? Just to clear that up, we can convert it. And now for sure we're checking number against number, right? And we'll return true. That's first case, second case, and we can just work down the line. The sum of the first 3 digits of the local number appears within the last 4 digits of the local number. That means it's spam. So before I iterated through and added the digits of the first local part together to get the sum. This time, let's reduce it. To do that, we could do someone once told me. No. Split. So we'll split it at, no, not a space. We'll split it, and now we have the string version of each digit, and now we can reduce it. And each reduction step, we are going to get the sum, or I can say previous value, and our digit, and we have to convert the digit. So we have the previous value plus parse int digit, because the digit is a string, because local 1 is a string. We just split up a string, and we start with 0. That second argument is kind of optional, because it's just going to start with the first value, but we need to parse the int of the first value, so it's helpful to begin with the 0 here. Reduce, if you're not familiar, is going to iterate through each character in our array, which is split up from local 1, which is, 234 or 309 or 435. We just split this up into an array of characters. These are still string type, but we will iterate through each of them, and on each iteration we will take the value we got from the previous one. The first one we start with 0, so previous will be 0, 0 plus the integer value of our current item, and then it'll go to the next one, and it'll take that sum as the previous, and that'll be that last sum plus the converted value of our digit, and it'll iterate through reducing it down to the sum. So we have our sum, and now we just need to check to see if local 2 includes the sum, and we still have to convert it back to a string. And if so, we return true, because it's spam, because spam numbers do that apparently. This is kind of going back and forth between an array of string values, converting it to a sum that is an integer, and then converting it back to a string to check against it, and that seems a little silly. So there's probably an even better way to do this. It's probably the best I got right now. And now our last constraint. Our last constraint I've been putting off because this might be a little harder. What we could do is use regex again, and we can just get the digits, only the digits, right? Before we matched and got each individual part of the number. This time we will get the whole number. Let's replace everything, anything that's not a digit. I was about to do uppercase D. I want to look this up. Regex uppercase D. Yeah, in regular expressions, the escaped uppercase D is a predefined character class that matches any character that is not a digit. So we've got a not caret, which I guess would have to be like in a capture group, I guess. I think we could do it this way. Also, it helps if I spell replace right. So we're calling replace. I think we could do this, but this would be more clear. This is like exactly what we need. Anything in the string that is not a number digit, replace it with nothing, clearing out everything that just isn't digits. Now we just have the digits, and that's much easier to act on for our duplicate check. We need four or more times in a row. Kind of curious. Yeah. Let's see, our regular expression would be capturing a digit that came before 3 times. Did I do that right? Let's think about this. Yeah, so let's test digits with that. I think. So open the regex, capture digit, our \1 3 or more times, including the one we're capturing. So it'd be 4. If this detects the same digit 4 times, I think that's what this would do. I don't know. I've been trying to get better with regular expressions, but it's hard and I hate it. And let's hope that works. And this, otherwise we return false. So this is what I think this is doing. It may not be right. And it bothers me that this slash is red. It's telling me I did something wrong maybe. But we capture a digit and we look backward up to 3 spaces. Is it the same, or 3 items? Is it the same digit? So we have 1 digit and 3 more that are the same. That would get us our 4 or more times in a row. Yep, let's just try it. I know I'm going to have to debug this, but if you look at this, it's a little bit more compact. It's a little bit cleaner. It might be a little bit more clear on what's going on. I don't know if this is right. I'm going to feel silly if I'm totally thinking about this part wrong, but for the regex stuff, I mean, this is much more clear if you know regex compared to that loop that iterates through the number and checks for previous duplicates, you know? All right, hold your breath. No, something's wrong here. So let's see. Area is read only. Oh, because I used const. So instead of area, let's do area code. All right. Little mistake there. Let's hold our breath again and cool. So that is my second solution to this challenge. Took me thinking about it a little bit more, but I think this code looks a little bit better than that first solution. So let me know what you think. Maybe you can think of a better way to do some of this stuff, or something that would just be more readable or more simple to accomplish the same thing. I'm really interested to know. Challenges like this, there's probably like 5 different ways to do all this stuff. And depending on who you ask, none of them are right, you know, because programmers are so critical and everybody has a better idea than everybody else. So interested to know what you think. If this helped you at all, if you learned a little something, maybe read up on some of the regular expression stuff if you're not familiar with it. It can be helpful to simplify your code. And yeah, thanks for watching. If you like this video, go ahead and hit that like button. I appreciate it. Subscribe to my channel, help out my brand new channel here that I'm trying to get started. Thank you very much, and talk at you later.